Hello friends, very good afternoon. Welcome to this webinar session on enhancing cost competitiveness through problem solving. Let me begin with the context. The corona pandemic is an unfortunate situation for the whole world, but we have to face it intelligently to neutralize its adverse effects on our life and on our business. In the current lockdown of industrial activities, we can see an opportunity also to detect deficiency of our processes and improve them to produce and deliver globally competitive products when business restarts. So the purpose of this webinar series is to facilitate industry managers to improve global competitiveness of their products. In the previous webinar, we discussed on how to detect problems using value stream mapping. In continuation of last topic, today we'll be discussing on how to solve the problems what we have detected during value stream mapping. So the corona, of course, it is bad for our economy and our health, but it has brought some opportunities for India also, like to accelerate Make in India initiative, what has been started a few years back by our dynamic Prime Minister. Now, this makes us to think how to become Atmanirbhar, self-reliant, instead of depending on China and other Western countries to get most of the things imported. So, this is opening an opportunity for global market to encourage our export. But to attain the exportable product, to become a global leader in manufacturing, we had to become globally competitive. And for the global competitiveness, this webinar series we are conducting, the very first one was how to detect the problems which is stopping us not to become globally competitive. For that, last week we conducted a webinar on the value stream mapping. This is a diagnostic journey that helps us to find out in our processes what is blocking our competitiveness. So once detection is done, the next one becomes how to solve the problems. So how to solve the identified problems to reduce cost, improve quality, productivity, and delivery. This is the theme of this current webinar. We'll be conducting another 3 on the 7 QC tools, inventory management, quick changeover, to support how efficiently we can solve the problem using various tools. So, with philosophy, life is a series of problem-solving opportunities. The problems you face will either defeat you or develop you depending on how you respond to them. In fact, the problem-solving skill is one of the most essential skills of life to make our life easier at home, in personal life, as well as at our workplace. So this skill everyone must learn and apply. Once we know this skill, then we can defeat the problem rather than we'll be defeated by the problem. So, agenda of today's webinar is that what is the challenge of 2020? Then TLS or TOC Lean Six Sigma problem solving technique. Briefly, it will cover how we can use it. So we'll be explaining this technique, how to use to enhance the competitiveness using a case study, actual case study of Comp Ltd. Then how to solve the problem, how to diagnose the problem, then problem solving step-by-step approach using the Lean Six Sigma approach, DMAC and A3 model. So friends, 1 hour is too short to present a big subject. In fact, I have undergone 20 days training of Lean Six Sigma Black Belt few years back, which was covered during 4 months with 5 days every month. So This is a big challenge for me to explain the concept of Lean Six Sigma with a case study within 1 hour, but I'll try to do my best how it can be presented to make you understand. So starting with what is challenge 2020? So the goal of every organization, every employee knows to continuously and consistently enhance profit. So what's the profit? The model is very well known. To increase the profit, we have to increase the revenue and decrease the cost. This is the very simple equation. But how to increase profit? There are 3 variables are there. Increase sales, increase price, or reduce costs. These are the 3 critical parameters to increase the profit. Now let's take one by one. Can we increase the prices? No. Today, the prices is dictated by the customers or the market. We can't increase the price, so we have to rule out this option. Then comes to the increased sales. Can we just increase sales without doing anything? Again, it is not in our control. It is in control of the market. It can be increased only if we are globally competitive, then only sales can be increased. Then how to make it competitive? The only option is left is the reduced cost. So this is as shown in the combining 2 methods, increasing sales by reduction of the cost. This is the only option left to us, and we have to prepare our processes, our people, and our product to become more competitive so that we can capture more market share and increase our sales. For this, we are going to use a technique called TLS, which is using 3 most powerful techniques of the world: theory of constraints, lean, and Six Sigma. So the most important question comes: what makes your products costly? During last webinar, in the value stream mapping with the lean principles, I clarified, in fact, what makes costlier is the waste. Why the waste is generated? Because some visible or invisible problems in our processes, right from raw material purchase to production to delivery of the products in hands of customer. So the problems are the main cause which are making generation of waste, which is adding to the cost. So how to increase sales and profit? The practical approach is now first phase, that identify the problems. For identification of the problem, we have to use theory of constraint and lean to pinpoint what are the problem points, which are the constraint area, so that we can rapidly reach to the solutions. Then the second phase comes once the problems are identified. Then to solve the problem, we are going to use a Lean Six Sigma problem solving methodology. The first phase was covered in the last webinar. Now we are going to talk about the second phase of the problem solving using the Lean Six Sigma. So the very clear, we should be focused. Challenge 2020 is reduce the cost, then only we can enhance our competitiveness and enhance our profit by selling more and more product. So how to reduce cost? Here, a technique called TLS techniques. Most of you must have heard, and many of you must have been trained also, the Lean or Six Sigma or theory of constraints. All 3 are today globally recognized the most effective and widely adopted problem solving technique. Fortunately, I had opportunity to get formal training in all these 3 techniques separately. So after exposure of all these techniques, I thought, let's find out the most simpler and the convenient techniques of Lean, Six Sigma, and TOC, and blend it to a new technique called as TLS and apply that in totality to solve the problems instead of using Lean or Six Sigma or theory of constraint. stand alone. How it has been used. TOC is one of the most powerful techniques which identifies the constraint in a system. Because we have to focus on constraint instead of all processes. Then once constraint is identified, we go on the micro level analysis, pathological diagnosis of the process, and identify the problems using the value stream mapping of the constraint process. Once a value stream mapping is done, that helps us to clearly identify what are the problems which are enhancing the cost, which are adding problem for the competitiveness. So very clear picture we get, very authentic, using a powerful tool. What exactly we need to address to become more competitive. So then comes the problem solving using the Lean Six Sigma. Here we have combined two very powerful tools, the math of the Lean and A3 thinking, which is most powerful problem solving technique used by the Toyota. So by combining the DMAC and A3 thinking, we are going to solve the problem. Let's see how. So I'll be taking through a case study how this problem can be solved. Let's take case study of Comp Ltd. Comp Ltd is a producer of automotive lubrication components. It's a Banjo hose pipe as shown in the slide here. It is used for lubrication of various parts of automobiles fitted inside the engine. So Comp is having three strategic business units for production of its products: bright bar unit, Banjo CNC machining unit, and hose assembly unit. During the year 2019, there was a good demand of Banjo hose assembly, but due to higher cost and lower productivity, company could not supply the ordered quantity. In order to improve sellability and profitability of its products during 2020, CEO decided to adopt TLS problem solving technique. So now I'll be explaining you how it has been used step by step to solve the problem, to improve the productivity, to reduce the cost. So the problems of Comp Ltd is two main areas: the higher cost of production and poor productivity. Of course, both are linked. Productivity is poor, then the cost goes up. So now let's come to how to solve the problems. Here, actually, we think problem is a problem, but actually, if you see, the problem is not the problem. The problem is our attitude about the problem. So first, we have to change our attitude towards the problem. I'm just going to give very nice example. All of you must have heard this story of Panchatantra, very famous, and incidentally, not only in India, I've seen in several countries this is a popular. As you know, the 6 blind men, they wanted to know how the elephant is formed. What is the form of elephant? They were exposed to an elephant for some time and always could touch some of the parts of the elephant, as you are seeing here, who touched the legs of the elephant. He thought it is like a tree. Another who perceived like a rope. And third one, he perceived the elephant is like a fan. The fourth one, he perceived who touched the body of the elephant like it is like a wall. And who touched the spear, he thought very sharp spears. And another fellow, hello, trunk, he felt like a snake. After all assembled, then they started sharing their experiences. Then all were adamant that no, you are wrong, only I am correct. No, elephant is like a tree. Another adamant, elephant is like a rope. So all 6 were adamant with that. But here the attitude, as I told you, holistic thinking. So Elephant was a combination of experiences of all six. So this is attitude we need. Even I have faced in real life situation in the shop floor. Any problem comes, everybody thinks only he's or she is correct, but it has to be seen in holistically. So this is the first transformation is required in the problem solving, to have holistic thinking, taking everybody's views, then only we can see the problem in totality. So how this problem can be solved of the cost reduction, the TLS technique, these are the 7 steps very clearly identified. First step is awareness of TLS technique. Awareness of TLS technique, basically to buy in the concept and change the attitude of people about the problem. The second is identify the constraint. Here, TOC is used. In the last webinar, I discussed in detail. Then third step, after the TOC, you have identified the constraint area. Then that constraint area goes for further micro level analysis by the value stream mapping. And from the outcome of value stream mapping, we have identified the problems which must be addressed, and from each problem that becomes problem solving project. So this was the first phase of the problem solving, detection of problem. Now, how to solve it, it comes in step 5 and step 6. First, step 5 involves form a project team and enhance their competence. Then once they are trained in problem solving technique, then work on the problem solving projects and solve the problem using DMAC A3 model. Let's see how it has been done in Auto Comp Ltd. Step by step, first step was awareness training, awareness understanding, make the people understand the concept. All the process people who are managing the business, they must understand the concept and they must change their attitude towards the problem. Then comes diagnosis of the problem using the TOC and lean technique. What are the problems? What are the constraints? What are the bottlenecks which are enhancing costs? Then third step is that problem solving. So the whole team of your shop floor or the process, they must be made aware by making understand the TOC Lean Six Sigma approach of the problem solving. Then comes second step is how to diagnose it. One of the key parameter in the production, though it is not very commonly used, this matrix throughput. Throughput is now very, very powerful parameter. In fact, this is the essence of all your efficiency. It can be defined the rate at which a processed material is passing through your processes. If I summarize that, throughput is the key parameter which you have to monitor and continuously improve. In the commercially, it can be called as rate at which system converts inventory into cash through sales. For the finance people, throughput is the rate at which money is coming in the system. So there are 3 ways to interpret the throughput: at what rate you are producing and delivering the product. Second is at what rate you are converting your inventory into cash by producing and selling it. And third is what rate money is coming in your company. This is throughput. For throughput, first you have to collect the throughput data of basically all 3 units, strategic business units. Capacity and throughput of 2019 was collected based on the historical records. So bright bar unit, it can produce up to 5,000, but it has produced only 4,000 units. Banjo machining unit, capacity was 4,000, but it could produce only 3,000 units. Hose assembly unit, 5,000 units, but it could produce only 3,000 units. So the constraint here basically comes to the Banjo machining unit. Bright bar can supply much more. There is no constraint of supplying the bright bars raw material for Banjo machining. Assembly unit can assemble more, but it was not able to get the Banjo. This is a component as shown. It is not being produced in enough quantity in the company. So this is a constraint is identified by that is very clear now. Instead of focusing all three strategic business units, we have to identify the Banjo machining unit. So this is the actual process you can see. You can see the left side is the bright bars, steel bars used. These are the automated machines. This is a small industry, and this is turning a solid bar is rough ball is turned, and you are seeing at the end. So these are the machines used for that one. Then it goes to CNC machines where it is a holes are made. Here the threads are machined, and specific shape is given a series of machining CNC machining units. So the third step becomes value stream map. This is a value stream map of the Banjo machining unit. Here I will not go in detail because it was covered in last. So I'm just showing you this kind of value stream map and the outcome of this value stream map. These are the production data collected for the value stream mapping. They are the 6 steps involved in the production: rub ball turning, CNC ball turning, facing, boring, facing and grooving, testing, chamfering. After that it is dispatched. The key parameters required here based on the lean key metrics: cycle time, changeover time, defect rate, and equipment availability. The actual data for the 6 processes were taken out, some made by the observation with the stopwatch, some by the historical. So these are the data of value stream. Data were collected, and based on the value stream map was created. And after the analysis of the map, these 3 problems were identified in the process, which is impacting adversely on the productivity and the cost. First is the cycle time. CNC machine operation are high and imbalance. This is one of the main reasons. This is one of the main reasons why productivity is less. The next is the tool changeover time is high, resulting to lower equipment availability. Then machine breakdowns are frequent, resulting to low productivity and poor equipment availability. So these 3 problems were identified by value stream map. So each problem has to be taken as a separate problem solving project. In this case study, we have taken the first one, cycle time reduction, as the problem. So selection of cost reduction project was done, the reduction of cycle time of CNC machining operation. So due to high and imbalanced cycle time, productivity is adversely affected, and WIP inventory is generated between the processes. Cycle time of following 3 operations need to be reduced and labeled to improve productivity. First one is the rub ball turning. The automate machines are used, facing, drilling and boring. CNC machines are used, facing and grooving. CNC machines are used. Now, how to solve the problems? Now you have to form a project team. You have to form a project team. These were the people, were the members of project team. Was the plant manager, was heading it, automate machine operators, CNC machine operators, quality inspectors, and lean expert. Incidentally, I was the lean expert in this project. Then once team is formed, then training of team members. Before they start problem solving, they must be competent enough to know the tools, techniques, how to solve the problem. Their knowledge and skill was improved by problem solving, training them on problem solving technique, 7 QC tools, inventory management, quick changeover. All these trainings were given to the team members. Once they became competent, then they started working. So again, a very important thing, we can't solve problems by using the same kind of thinking we used when we created them. This wisdom was given by the greatest scientist of the century, Albert Einstein. In fact, if we try to solve the problem with the same knowledge by which we have created, we can never come to solution. So we need to learn something new. Then only we can solve the problem. This is again one of the attitudinal transformation of the problem solvers. This is very important. Don't try to solve the problem with the same limited knowledge. You have to learn new techniques, then only you can find the solution. So what's problem solving approach? If you see the current state to future state, the improved state, you have to make a target, and the gap is the problem. What is the problem? The gap between the current state and future state. Here we have to learn together to solve the problem. And it cannot be done in one go, step by step, using the very famous methodology given by the Deming PDCA, Plan, Do, Check, Act. So the PDCA, the Lean and Six Sigma is nothing but PDCA in the modified form. So we have to learn together for a new technique, then only we can reach to the future state, the solve with the solved problem. Let's see how it works. Lean Six Sigma, the MAC A3 model, nothing but Plan, Do, Check, Act. All techniques, whatever you are following, based on the PDCA. Six Sigma, the same PDCA has been made in 5. Define, measure, analyze, improve, and control. 5 phases. Here, the Lean, the best company of the world, Toyota, which is recognized globally, they are using A3 thinking steps. And the whole world is trying to learn A3. So in this particular model, I have combined DMAC and A3 together. So A3 thinking involves 8 steps. How this Lean and DMAC, Lean approach and Six Sigma approach has been applied in the problem solving in the 5 phases is being used. So this is the way. The define phase, the problem, define the problem in terms of what is wrong and clarify the problem. The second phase is the measure the non-conformance and abnormality in the processes. So here the A3 involves break down the problem, collect data, and set the target. The DMAC approach, third phase is the analyze the situation and establish the root cause. So with the A3, we have to develop countermeasure and reach to the root cause. Then fourth phase is to improve by implementing the countermeasures. So how to implement the countermeasures and evaluate the results and process. And finally, fifth one, once we have solved the problem, we have to hold the gain, we have to control through the prevention of recurrence of the problem, so standardize the process. So the DMAC A3 has been blended in a 5-phase manner. After learning the DMAC technique, the schedule was made for 6 months, how the define, measure, analyze, improve, control, and the 8 steps will be done. A 6-month schedule, step by step, was prepared, which was supposed to be followed by the team members. Now let's begin how the problem solving has been started. The very first phase, define. So as I mentioned, what is the problem? The gap between the way things are now and the way they should be, or you want them to be in the future. The manager has a problem when the work assigned fails to produce the expected results. So the problem is a gap. We have to identify the gap. The define phase, the very first step in the successful problem solving is clarifying the problem. The clearer the problem, faster we can solve it. How it can be done? These are the steps. First, clarify the problem, specify customer value, define the problem, define the project scope, identify project resources, and develop project management plan. So this is the more of bringing clarity, more of planning it so that it can be done very fast. So how to divide the responsibility so that there is no confusion among the team members. This is equally important. It is called RACI chart: responsibility, accountability, consulting, and informed. 4 types of people are there. There are some responsible, some accountable, some consulted, and informed. All team members very clearly defined who is responsible for each activity, who is accountable, and who will be consulted, who should be informed. This way, the total assignment of problem solving is distributed clearly among all team members so that there is no confusion and the things can be done fast. Then comes, we have to collect first, starting with the current performance. This is called grasp the situation. What is the current state of the process? Here, if you see the 5 months available data were collected, what was the customer requirement, average units per day, and actually supplied. So the average was more than 4,000 up to 4,500. That was the demand of the customer, but average supply was not more than 3,000. So there was a big gap. There was good opportunity, but because of the constraint in the process, they were not able to supply. So the first thing, clarify the problem. Here, though demand was 4,500 per day, but we should not jump to conclusion. Let's go step by step. So the current actual production was 3,000. Then the team decided a realistic target was set. Okay, let's first increase our target to improve by 20%. Once we achieve, then again we'll go for the further improvement. So a realistic target was fixed. Okay, the current level of 3,002, we have to achieve 3,600 units per day. So what is the problem? The gap was there was shortage of 600 units per day production. That is the problem. So we have to increase our production by 600 units per day by solving the problem. So after that, a problem definition was made. It should be made in such a way so that all members, they can understand the problem in the same common language. So what was the problem definition? Banjo production unit is not able to meet the customer demand due to low productivity. Demand is 3,600, but it is able to produce only 300 units. So because of the constraint in the CNC machining unit. So the definition is clear, schedule is clear, clarity is there. Then comes the second phase of it, measure it. We have to get the actual data. So what's a measure phase involves collection of relevant baseline data, establish current state, and data collection should be done. So what are the activities involved in the measure phase? First is break down the problem. To get the real picture, we have to break down into small elements, develop process map, decide what data to be collected, validate measurement system, and collect the required data, and then set the target. So process information, customer demand, the problems, plant operation, plant problems, inventory, process, raw material, all were discussed by all the team members and documented so that everybody comes to on the same level of understanding. So the process information was collected and it was shared by the people. Then it was broken down. So different steps. First one was the rough ball turning, CNC ball turning. So 1, 2, 3, 4, 5, 6 steps were involved, and the cycle time was the critical thing. So cycle time of each process was collected using the stopwatch, using the industrial engineering method, and several readings were taken and recorded. So the total lead time right from the beginning to end, that was to be reduced, and the cycle time was the challenge. So the process map of Banjo production line, if you see, the same one is more clearly the ball turning. So these are the 4 main processes need to be addressed. Magnetic particle testing and chamfering was not a problem. So the focus should be on the drop ball turning and CNC machining processes. So measurement of current cycle time, because the cycle time reduction is to be done So all these processes, the cycle time set of number of data were taken and the mode was taken as the baseline. So operation time was 45 seconds, 20 in ISC, and 2 number of machines are used. The actual production cycle time is each 1 unit is produced by that machine. It comes to 25, 2.5, 20, 22.5, and 25 seconds. These 4 main concerned machines, this was the cycle time. What is cycle time? It is from entry time to the exit, loading to unloading. This contains the process time or the value added time, all blue, and the waiting or non-value added time, all red zone, that contains the cycle time. Then this is a new parameter. Of course, I discussed it. The cycle time should be matching to the takt time, the demand rate. Now the company want to produce 3,600 units. So based on that, the demand rate was calculated. This is a 20 seconds. It means each workstation must produce 1 unit within 20 seconds. Then only it can deliver 3,600 seconds. Because of the time shortage, I am going fast. So you can again see on the Google, the whole presentation will be there. So the cycle time was up to 25 seconds, but here demand rate has come to 20 seconds, it must be produced. The whole lean philosophy is balancing cycle time and takt time. Means your problems should be solved, then only takt time can be, and the production cycle time will be equal. Once this becomes equal, then only you will be able to produce and deliver competitively to the customers. So based on that, new targets were set for all these 4 critical processes. The earlier cycle time was 22.5, 22.5, 25. So for all the processes, now they need to have a cycle time 20 seconds. This was the target set. Then now come to the third phase. Now analyze the root cause. Why cycle time is more? This is a very critical. Here, analyze phase needs a lot of expertise of the operation people because you are the expert of your process. So the purpose of analyze phase is to reach the root cause. So what are the steps involved? Gather facts through process observation. Here the actual data is required. You have to observe the process critically on the shop floor, collect the actual data, analyze the root cause jointly in a team using the brainstorming, determine the root cause. There may be so many things. You have to come to the one point of root cause and then develop countermeasures. What are the solutions and develop improvement. This is a very critical and it requires all your knowledge of your process and your problem solving Lean and Six Sigma tools. Both are knowledge is required to find out the root cause and develop solution. So cycle time analysis is done. If you see the actual cycle time of all these 3, you will find the 4 are different: 22.5, 20, 22.5, and 25 seconds. It means all cannot produce what is needed. So what need to be done? This is graphically, if you see, this is a very, very powerful tool. So once you draw it, takt time was 20 seconds. Whatever coming cycle time more, if it is more, means it can produce less. So all operations cycle time must come under the red line of the takt time. Then only you will be able to produce. So the challenge is to reduce the cycle time of these 3 processes: rub wall turning, RBT, facing, drilling and boring, and facing and grinding. So it has to brought down below 20 seconds, then only you'll be able to produce 3,600 units per day. Now, the root cause, all of you know the cause and effect diagram that was used, and the Why-why analysis. These are the 2 most common and most effective tools are used. So the whole team, after the knowledge of these 2 techniques, they identified the root causes. Rub ball turning has limited capacity. CNC ball turning, there is no problem at all. It has got a 20-second time. Facing drilling and boring, high-speed steel tool becomes hard at higher cutting speed. Facing and grooving, tool changeover time is high. So these were the regions. Then the solution development, again your knowledge of operation, your technical competence is required. Only the people touching the process, only they can find the solution. Here you can involve the expert senior people who has got a deep knowledge of these machines or the subject. And one very important, the equipment suppliers, the machine suppliers, tool suppliers, they can give the solution. In this case, I asked the plant manager to call the tool suppliers, and they really contributed a lot to find the solutions. What are the solutions? Rub ball turning, use one or more machine. Incidentally, they had one idle machine, so that was put in practice. CNC ball turning, maintain current cycle time. Facing drilling and boring, third problem, introduce rotary tools, use carbide tools. And fourth one was the reduced changeover time. So these were the solutions devised by the team. Then how to implement the solution, another improvement action plan was made in weeks, how it will be implemented. Then comes to the improve phase, means now putting those solutions in practice. So what requires it? The improve phase is systematic approach for testing and implementing the countermeasures to solve the problem. Following activities are performed in this phase. See countermeasures through. Here you have to apply your willpower and confidence, not give up that. There may be problems in implementing, but you have to continue your effort. Then make a pilot run, then evaluate results and process, stabilize the process. So this is a countermeasures through, never give up. Maybe problem, so you have to take very strong willpower. Maybe in the beginning you may fail sometime, but don't give up. Again, rectify your efforts. And here the confidence and the willpower is very important for implementing the countermeasure. Then comes improvement actions. After the implementation, the actual data were again taken. The target cycle time was 20, and the actual time, in fact, some of the operations, the cycle time was achieved lesser than what we targeted. In the rub ball turning, target was 20, but we could achieve 15 seconds. Second CNC ball, 20, 16 seconds. Facing drilling, 20 and 16 seconds. Facing and grooving, 20 was the target. It was only achieved 20. So these were the results obtained after that. Now evaluation of result was done. If you see all the processes with the takt time of the green line, and if you see the blue graph, which we are showing, the cycle time was more than takt time. And then after the implementation, all were brought down below the red one. After the improvement, all were brought down below the takt time. So it means that now all units are capable to produce 3600 because their cycle time has been improved. So results of improvement, if you see, it was evaluated. Process cycle time maximum was 25 seconds. After TLS, it was brought down 20 seconds. Productivity units per hour, it was 184 units per hour. These to 242 units per hour. Productivity improvement was 30%, and sales revenue was increased significantly. So reduction in production cost of each item, if you see, the cost has been calculated by their cost accounted. So the total annual production, 900,000 units. After TLS, it was increased 1170 units. Revenue was 14 per unit. The production cost 1190 units, and after TLS, it reached to 11 rupees 42 units. So reduction of 48 paisa per unit was achieved by improving the productivity. So after achieving the good results, now this is a very important your processes are improved to hold the gain. It should not come back again to the old performance level. So the control is one of the very important phase to hold the gain. What it involves: develop standard work, then make the people more competent on the new approach of the process, improved process, so that they can continue production with the same spirit, with the same production performance level. Then continuous monitoring of performance, then reward and recognition system. So standard work is one of the very powerful lean tool that it specifies the exact sequence of every activity and and the cycle time for every activity. And third is what should the maximum inventory at each station. So this is right from the material input to the delivery, the material and parts, machine equipment, methods, people, measurement, everything is quantified and everything is put in a sequence of operation, and for each operation how many seconds is required, that is given in a sequential way. I can't cover in a limited time. This is a very, very powerful tool, one of the greatest success of Japan, the standardized work. Then develop people to adopt new way. Earlier the people are habituated doing in their old method. Now, but many things has been changed, what we have seen in the improvement phase. Now, those practices must be programmed in the mind of the people. All the operators, they must be educated, they must be trained, they must be empowered, and they must be rewarded, encouraged for the better productivity. So development of people to adopt new way. Actual change, if you think, is needed in the knowledge and the skill of the people. So with the standardization, the control phase to make sure that the new improved methodology is well programmed in the people. It becomes their regular habit. So a lot of training effort is required so that people are changed to adopt the new way of working. Then comes performance monitoring. One of the famous statistical quality control tool called the control chart. As you see, there will be always variation, and the red lights you see the upper control limit and lower control limit. This must be recorded every day, every shift, how the production performance is. If any day, any moment, it is crossing upper control limit or lower control limit, it means there is something wrong happening. So monitoring can be done with the control chart. After the success of the project, everybody must be motivated. The whole team, they must celebrate the success. This is very important, whether you are a small unit or the big unit, you must give opportunity to the operators who have done a good work. So there are two things are there, recognition and reward. There is a big difference in recognition and reward. Reward is a tangible incentive. It can be in terms of the financial incentive or some gift is there, some kind. But the recognition is to raise the self-esteem of the people. They must feel proud to make this improvement. Their self-esteem must be improved. This is one of the Japanese way of respecting the people. They must feel that they have got a real ability to make the improvement in their process. So the recognition is appreciation, so it raises the self-esteem. So both the methods must be used, recognition and reward, for the motivating your team and the people. Now just summarizing, following actions are recommended to solve the problem. Conduct value stream mapping of your all processes. Select cost reduction projects to improve the productivity, quality, reduce inventory. Then learn TLS problem solving technique. Then follow, define, measure, analyze, improve, control, and A3 model to solve the process problem. as I explained you. Then coming to that, running away from any problem only increases the distance from the solution. The easiest way to escape from the problem is to solve it. Don't be afraid of the problem. As in the beginning I told, life is a long journey of problem solving. Ultimately, who are the best problem solvers? Only they are reaching at the top. Just analyze the successful people, whether in corporate world or political world, in the leadership, social, everywhere, those who are the problem solvers, those who grasp the problems as an opportunity and found out solution and solve it. So the problem solving is a big challenge for every professional manager to demonstrate his knowledge, his skills, creativity, and competence. So take problem solving as an opportunity for demonstrating your real creative competence. So the reference book, all this what I have discussed is covered in detail in this book based on my experiences. I wrote just few months back, it was published. You can get very detailed description of all these things and the concept behind it. So with this, just at 5 o'clock, I'm able to conclude this webinar just in time. So thank you for patient hearing. Now I'm open for question and answer sessions. You are most welcome to contact at these mail IDs, Tata Steel people, or directly to me through them. So now session is open for the question answer.
Thank you, sir. I would request all our attendees to either raise your hand for questions or to write the questions to us on the questions tab, and we will answer them shortly. Question is, what Six Sigma means?
Six Sigma is a measure of variation. Of course, this requires long session to explain it. It's not easy to understand in a short question. So this is what causes defect is the variation. Variation in the materials, machines, method of operation, or the operating practice by the operator. All these variations, they cause defects. Six Sigma is the measure of variation. The bigger the number, lesser the variation. So it's really practically impossible to explain this one. The whole concept has to be explained. In fact, earlier I conducted full session on Six Sigma. I'll repeat someday. Then only it will be clarified. But at this one moment, I'll say that this is the measure of variation in the 4 M's of any process that causes defect. So if larger sigma value, it means the lesser the variations. So we have to increase the Six Sigma statistical terminology. So at this moment, I'll just say it is a measure of variation that causes defect. Okay?
Yes, sir. Moving on to the next question, it is, all the theories that has been discussed today are very important and relevant to MSMEs, but not all MSMEs owners are educated. How can we help them?
See, frankly speaking, I have undergone 20 days training on Lean Six Sigma. It was conducted over 4 months, 5 days per month, then some practice, 20 days. So here, basically, as I told, that's why I tried to combine TOC, Lean, and Six Sigma together to make it simple for MSME, and implemented more than 40 MSMEs under Lean Manufacturing Program. It can be done. It has been done. They have to learn. They need not go in the very sophisticated statistics. It can be learned by them, but they have to invest time, effort, and some money for learning. Very simple thing. They have a lot of consultants are trained. The government is supporting through lean manufacturing schemes. They can approach MSME department. They can get registered, and I think more focus will be by the government. Zero defect, zero effect. There are so many schemes. The lean consultants, they can help them to learn and put it in practice. Okay.
So the next question is how to measure practice of operator and identify defect.
How to measure?
How to measure practice of operator. How to measure practice of operator and identify defect.
This is a tool called as cause and defect diagram. You have to learn the cause and defect diagram, which wrong operation has caused the defect. The techniques are there, tools are there. See, unless all various tools are learned by the people, you cannot find out the solution. So a lot of investment in learning is required. There are tools are there, Why-why analysis, cause and defect diagram to identify what causes the defect.
Right, sir. The next question is, in this post-COVID time, to manage productivity with less manpower is a challenge. Keeping physical social distancing while working together. So how shall one work in this situation, especially in sheet metal stamping and auto industries?
So this question cannot be answered on imaginary situation. This is something means physically it has to be seen. Relevant data has to be collected. Then only answer to such situation can be given. Means I can't give, or nobody can give without knowing the process. Means one has to take the data, one has to understand the step of the process. Then only solution can be. It cannot be just imaginary. It cannot be the generic answer for everybody. It has to be specific, individual process. It has to be studied, observed, and data has to be collected. Then only solution can be.
The next question is, how does Six Sigma relate to 5S?
There is no relationship in Six Sigma and 5S. Both are different things, right? So directly there is no relationship. 5S is the workplace organization. Six Sigma is a statistical technique to reduce the variations. There is no direct relationship.
Moving on to the next question, how to balance the profit even though we are not getting firm schedule from customer?
Again, here, these are the actual data analysis is required. So the how much is profit coming, then the cost accounting comes. Here, we are just talking about the productivity improvement. So these are based on the actual cost of production, all this data. It can be just accounting exercise. This is not possible to give any generic answer to this one.
Thank you, sir. That was the last question.
Okay.
Thank you for your interactive session. We would like to conclude today's webinar here.
Okay, Sean. Thank you.
Thank you, sir.